Welcome. Today we will be discussing the common methods of construction with wood framing materials, particularly as to those materials developed after the rise of the industrialization of America. In the decades before the Civil War, the first industrial revolution was a transition to new manufacturing processes. This transition including going from hand production methods to machines. After the Civil War, the United States emerged as an industrial giant. Old industries expanded and many new ones, including petroleum refining, steel manufacturing, and electrical power emerged. Railroads expanded significantly, bringing in even remote parts of the country into a national market economy. Industrial growth transformed American society. It produced a new class of wealthy individuals and a prosperous middle class. It also produced a vastly expanded blue-collar working class. Growth in the construction sector grew as well. The demand for more and better housing paralleled the increase in commerce and manufacturing. As with most aspects of daily life at the time, the dissemination of information facilitated the advancement of many trades, including the building trades. In the building trade, the most widely adapted advancement was called balloon frame construction. However, while this adaptation had many advantages over more laborious and time-consuming building methods, it had one insurmountable drawback. It had an inherent design flaw which put in jeopardy its occupants. Nonetheless, it is important to discuss balloon framing as some structures still do exist today. As building professionals, we need to be able to recognize the framing method and understand the implications of working around the potential hazards. Remember, it is our duty as licensed professionals to, above all else, including above the interests of our own clients, to protect the health, safety, and welfare of the general public. Just as an accountant uses mathematics as his language to communicate, and chemists use formulas to communicate, and a mathematician uses equations, as building professionals, we have our own vocabulary within which we need to be conversant. Today, we will speak the language of wood frame construction with its own elements and descriptive notations. There are a limited selection of woods which have the strength to live up to the stressing demands when incorporated into a building as a structural element. Not all trees are created equal. Here we see the slide of the stresses of dead and live loads exerting themselves on a structure, pushing downward to the earth, and the earth resisting equally that same load in the opposite direction. As we discussed, this is one of Newton's laws. Pictured here are footings. On the footings will sit the vertical walls of the cellar, crawl space, or first floor. In the picture at the bottom left, the formwork into which will be poured the concrete walls of the structure are being built. The footing, pictured in each of these slides, is the element of the structure upon which will rest the entire weight of the live and dead loads, and they're spread over a couple of feet width of soil or undisturbed earth. They are the point where the building structure meets the ground. You can see in these slides that there are reinforcing bars projecting out of the footings. They will tie in the foundation wall, whether it's of a basement or a cellar or just a plain concrete slab on grade. These are reinforcing bars that we spoke about in an earlier module. They come in various lengths and cut on the job after being positioned into the concrete before it is poured. In our New York metropolitan area, the line in the ground below which the earth does not freeze is about 4 feet. So we see that the footings always have to go below the frost line, so they're not subject to heaving, pushing up, and settling, going down, with the fluctuation of temperatures, particularly in winter. Here's this grid. It shows the grid of the reinforcing bars. They're set into where the concrete will be poured at those points where the engineer has identified that there will be tension stresses on the concrete, and as we know, the concrete will not withstand much tensile stress. If the excavation is also above the water table, the space excavated could be designed as good usable space. So here we see a basement. Here's the grade up here, and we've dug down below our frost line, but also enough to give us headroom in a basement, and we still haven't penetrated the water table. The water table may be here. It may occasionally rise, and there are some drain tiles or drain pipe with perforation, which will allow that water to go into those weak areas and be brought away to an area below the level of the basement floor, so that the water, if any, could flow downhill because of gravity and then somewhere out into an open area where it will dissipate. Hopefully not into our neighbor's yard. That would be problematic. But you can see here that the concrete is sitting on, the concrete floor is sitting on undisturbed or virgin earth, which has been compacted over the ages by natural forces. The house, its structure itself, the exterior walls are sitting on that foundation wall. These are those foundation walls, and they're sitting on the footing. The footing is giving the weight a little spread, maybe 2 feet, for heavier loads, maybe more. But the footing is lying horizontally on the earth and absorbs the weight from above and dissipates it into the earth below. Those footings are concrete. We talked about concrete being a combination of cement, water, and aggregate. Here you can see the aggregate is stone. This is for typical concrete, maybe a sidewalk or a foundation wall. Here's a piece of concrete where the aggregate is much more pronounced. Maybe the architect or designer was trying to make more of a statement, but they're much more visible, and they do have some kind of attractive expression of the compositional makeup of the concrete. And finally, I do have a sample of a portion of a cylinder. We talked about those cylinder tests when we talked about concrete, and I just wanted to show you, this is a piece of concrete testing cylinder that did fail ultimately, and we were able to track from that the loading capacity of this concrete, that it met the engineer's specifications and our expectations. You can almost see that there was a piece of rebar here. It just left its mark indelibly into that concrete. Together with excavating down deep enough to find undisturbed ground and being below the local frost line, the foundation for the structure should not settle, heave, or move. So here we can actually see contractor measuring down to see how far below grade that hole is. Make sure it's below the frost line. As I said, in this area, it's about 4 feet below the ground surface level. And he can also possibly tell that this is undisturbed virgin earth, and then they start their excavation. So he probably has some knowledge of the color of the earth being indicative of undisturbed earth. He may have also had that soil engineer come out and do some test borings or test digs to see what level the undisturbed earth could be expected at. So at this point, the excavation has begun, and the ground where the footprint of the building will be located is leveled to the elevations that are needed. So just going back for a minute to an earlier slide, once that field is level to just below where it needs to be to pour the footings and pour the concrete for the cellar or the basement, the footing is framed up using wood members. The steel reinforcing bars are put in place, held in place by wire, and the first stage of the concrete pour for the house begins. In this photograph, perhaps you can see the footing and a small portion of a crawl space wall. It's not very high because this house is not having a full basement or even a partial basement or cellar, but just a small crawl space, maybe 2 or 3 feet high above the ground, just sufficient to have one person get in there, perhaps run ductwork or piping or electrical wires, just enough workspace so individual contractor could get in there and do some necessary wiring or piping. But once that foundation wall is poured above the footing and the height of the first floor is established, we install what's called a sill. The sill runs around the perimeter of the exterior of the building or house, and it's secured using anchor bolts or other types of straps to that foundation wall. There's always included, before you put the wood sill plate on the concrete, a shield, whether it's styrofoam or metal. It's a wood-boring insect shield. It prohibits wood-boring insects from getting from the ground to that first piece of wood called the sill. We don't want any insects eating away at that sill. It would undermine the structure of the house, of course. If those sills, for instance, were to be rotted away, the house would start to lean to one side, and many times older houses do have that as a problem. Today we use what's called pressure-treated lumber. It means that the lumber will remain unaffected by the moisture that might be in the concrete from rain or driven wind. I'll show you here a sample of wood that's been rotted away. You can see that it's pretty ugly and it's lost its strength. We need to prevent that from happening, because the sill plate is what's going to hold the rest of the house securely down and in place. We will be discussing the issue of wood shrinkage later in another module, but for now I just want to say, because of the method of harvesting lumber as green or wet lumber, and the need for that moisture to be removed from the wood in order to stabilize the wood size, we do have to take into account some difference between the harvest or actual wood size and the seasoned wood size. In other words, once the moisture is driven out of that wood, we call that seasoning, and the wood, because of the loss of the moisture, shrinks. So for now, let's suffice it to say that when we harvest a standard 2x4, after it's seasoned, it becomes a 1.5 by 3.5 inch piece of wood. So we refer to it as 2x4, but in reality, when we draw it, and because that's the size that gets delivered to the job, we design around a 1.5 by 3.5. So here is what we call a 2x4, comes in different lengths, which we'll discuss in the wood section in another module. But when it's harvested, this is a 2-inch dimension and this is a 4-inch dimension. And in the old days, that was what they would cut and harvest, and that's what would be delivered to the job. But the house or the building, because of the shrinkage over time of the wood in dry weather, and then the expansion of the wood again in moist seasons, would cause the house to move and groan and swell and shrink, swell and shrink. So there was movement, there was cracking of the plaster, there were expansions and contractions in the house that became visible, jeopardized the actual structure, but of course was also very unsightly. So we have what's known as a 2x4, actually being 1.5 by 3.5 for purposes of drawing and understanding how the construction goes together. We have a 2x6, which is actually 1.5 by 5.5, and then different sizes after that. Here is a 2x10. It's actually a 1.5 by 9.25. I say 9.25 because after a 2x8, the increase in the shrinkage goes from a 1/2 inch to 3/4 of an inch. I wanted to show you as well that when we draw this material in elevation or section, because we are seeing in elevation only 4 edges, we're not drawing what's in the center, so we can't really be sure of what it is in a drawing that we're looking at. So we take our drawing and we mark an X at the end of it. That way we know that that's the end of the material. We're looking at it in section. We're not just looking at something blank right here. The same is true with other size lumbers. I don't know if you can see there's a red X here. So when we're looking at face on, we're not just seeing four corners or four edges, but it makes sense that this is actually not a void, it's a solid. The anchoring of the sill plate is intended to resist lateral forces, right? We talked about primarily from wind on the structure itself to prevent it literally from blowing off or moving off its foundation. In these slides, you can see the anchor bolts. These are embedded reinforcing bars or large bolts embedded into the concrete for full resistance to the loads that are going to be on the house. Here's the foundation wall. Here's that insect shield. Here's the pressure treated sill plate. And here is the anchor bolt. There's a nut on the top there. That sill plate is secured down. Then the framing, the wood framing, the house is going to truly begin. You can see here, this house has been literally blown off its foundation because the sill plate had rotted. The sill plate is typically a 2x6, right, which we said was 1.5 by 5.5, laid on the flat on top of the concrete foundation wall. And where those anchor bolts do occur in the concrete, we drill out a hole, typically a 1/2 inch, lay that in, the bolt goes through it, and the nut goes on top, and that's where our rest of our wood structure can rest. Here's the anchor bolt, here's the sill plate, here are the exterior walls. It used to be, before the energy codes were developed in about the 1970s, that the plate around the perimeter of the house was only 2x4s. Here's a 2x4. But after the energy codes came into effect, we had to go with 2x6s because the insulation that was required in the exterior walls to keep the house thermally protected could not fit in a 2x4 wall. It could only fit in a 2x6 wall. So the sill plates became 2x6, and then so too the studs that sit, the exterior wall studs that sit on those 2x4. Here is another type of fastening for holding the sill plate down. In addition to the anchor bolts, there are other methods. You do want to make sure that sill plate is securely set. So find another 2x6. This is our exterior wall. On top of that sill plate, for the exterior wall, we put studs. The studs go upright and form the exterior skeleton of the house. And the stud, which is this piece that forms the wall, sits on the sill plate and is toe nailed in. This is how the toe nailing is done. Nail from each side. A nail from each side is driven into the top of the studs at the plate up above, because there's a top plate directly above the bottom plate, and into that stud through to the plate, whether it's the top plate or the bottom plate. So I mentioned sill plate. I mentioned briefly studs, which I'll talk about a little more. I do want to jump though to the joist. The joist is a joist irrespective of the structural material it is made of, whether it's a truss, whether it's wood, whether it's steel, whether it's concrete. So our foundation wall, our sill plate, and sitting on the sill plate are the joists. The joists are the framing members that span from wall to wall. You can see here from wall to wall on the other side, making either a floor, you can see here, or a ceiling. And the ceiling can be the ceiling just to the level below the attic, or it could be your first floor ceiling making the floor of the second floor. Once our joists are in place, and they're placed every 16 inches on center, 16-inch being a standard that everyone in the field or in the trade knows, 4 feet represents the size of gypsum wallboard and as well the size of plywood. So that if we space 3 joists every 16 inches, well, we'll be putting our gypsum board on the stud wall or our plywood flooring onto a joist. If we center that piece of board in the middle of a stud or a joist, we have established a 16-inch rhythm. So the board, gypsum or plywood, and plywood I'll talk about a little more, but it's this striated wood that you might be familiar with, we'll be able to share the first joist and screw down our plywood. 16 inches later, we'll screw our floor down again. 16 inches later, we have another place to screw our plywood down. And at the end of the third, it's 16 times 3, that's 48 inches. We should hit another floor joist squarely in the center. So we can screw the edge of our gypsum board for the wall, or whether it's a piece of plywood, again, 4 feet wide, we can always find the joist to screw into, or the stud to screw into. So 16 inches on center, meaning on center of the object to which it's going to be screwed, is a common dimension that every tradesperson understands. So here we see these floor joists. We know that they're all spanning from wall to wall, or wall to center span, where there might be a beam or a girder supporting the other end. 16 inches on center, and on the face of them, just on the edge, outside edge of the sill plate, is toe-nailed a band. It's called a band. You can see it here, which finishes the cavity ends of each of those floor joists. So here's a good example. Here are these joists are made up of wood I-beams. We talked about the I-beams. So you can see that here, if this is a 2x12, this also is similar in height, but we know that whereas this can only span maybe 15 feet clear span, this could maybe go 25 feet or 20 feet clear span for only a little extra depth. So we can play our hand either way. If we don't care about the span so much, this is going to be less expensive. If we do care about the span, this is going to be only slightly more expensive. But if our design calls for openness, this is what we'll go with, because this won't give it to us. Our walls will have to be closer one to the next, or we'll have to have an intermediate column support. Before I go on, I just want to show you in this diagram the foundation wall, the sill plate, the band, and the joists, all framing on that sill plate. And then this is now a platform for installing our subfloor. Our subfloor is typically going to be an outdoor grade of plywood. Plywood is, again, an engineered type wood where there are different layers of wood chips or shavings that are formulated under adhesive and pressure to be a superior wood material. Older houses, if you take the finished floor off, whether it's carpeting or some type of finished wood floor, if you take that off, you're going to see that the subfloor was made out of strips of lumber. Not as good as today's materials, but certainly good. Depending on the condition of those subfloors, if you're doing a renovation, you might want to take up that subfloor altogether. We're going to see some pictures of rotted subfloors and where you would want to replace with modern material. So the word joist, just as our other vocabulary words we're being introduced to here, is a term of construction jargon. So I said whether it's made out of wood, whether it's made out of metal, whether it's a truss, they're all called joists. It's often desirable to have a space uninterrupted by support columns or walls, just as a space of vast expanse. Perhaps this is one of your clients' requests. In our crawl space, which I talked about earlier, we do have an intermediate post. We don't really care because nobody's occupying the crawl space. So as I said, it's often desirable to have a space uninterrupted by support columns or walls, Just a space, a vast expanse. Maybe we are having a living room or a great room. We just don't want any interruptions. So we use our engineered lumber for those greater lengths that we need. This is another piece of, or another type of engineered lumber. Apart from that I-beam that I showed you, these are called microlams. They're like plywood, except on a grand scale, where the layers are alternating in direction, and the wood strength comes from that alternation of direction of the wood. So I-beam engineered wood, microlam engineered wood, plywood type of engineered wood. This is a shelf material. This is not engineered. That's a real piece of lumber. We do have our regular types of lumber. This is a 2x6 piece of lumber. I think you can see that these are real pieces of harvested wood. Suppliers of building materials generally manufacture construction items which fit and match together well with component parts manufactured by others. For instance, gypsum wallboard, as I said, as well as plywood, both come standard in 4-foot width because these manufacturers know that framing convention is that studs and joists are installed every 16 inches on center. In this way, if the carpenter places the edge of the first board at the center of the stud or joist, then the opposite edge of the board will land squarely on the center of the third stud or joist as well. It is important for two boards to be able to share the same stud or joist, as this cuts down on wasted time and material. Here's another example. If studs and joists are typically set 16 inch on center and a 2x is actually 1.5 inch wide, that leaves a cavity opening of 14.5 inches to accept the standard 15-inch wide insulation snugly. The insulation manufacturers understand this when they sought to establish the width of their product. So I'm going to show you a piece of insulation. This is a nice piece of very manageable insulation. It's actually made out of recycled blue jeans. It's soft. They call this cotton armor. We call this cotton armor. It's made, as I said, out of blue jeans, and it's eco-friendly. People can work with this with their hands and without a breathing mask. You're going to see some examples where other materials, such as fiberglass, are very unfriendly, feel terrible, need to work with gloves and face masks because you don't want to breathe in those fibers. Very scratchy, very itchy, very annoying. I'd like to show you one more type of engineered lumber. This is called a glulam. It's basically standard pieces of lumber, like a 2x4, stacked one on top of the other. I hope you can see that. And glued together with an adhesive of superior strength. This gives us another option for creating clear spans. And there are charts and calculations available and engineer reports as to how far some of these different types of manufactured lumber can span based upon their performance specification. So let's continue through some of these slides. Here we see the wood available from the distributor. Your carpenter or yourself would go over, purchase the lengths of the material type that your job. You can see that many of the pieces may have some inherent imperfection. Here this one is twisted or bowed, some come warped. So a good carpenter will go to the job and actually hand select the lengths that he wants delivered to his job, thereby culling out the bad pieces that he would have to otherwise reject on the job. I just want to show you an example of the clear span that I was talking about. Regular lumber or engineered lumber have a distance over which they should not be used or stressed. Spacing is center of joist or stud to center of joist of stud. That's a pattern, therefore, that repeats. So when we talk about on center, we're actually establishing a rhythmic pattern. The longer the span, generally the deeper the joist, right? Whether it's engineered lumber or regular lumber. That the depth of the joist is what allows it to span the distance. So when we have our joist 16 inches on center, or even our studs 16 inches on center, creates the cavity. I told you before that we could inset some insulation, but we could also inset ductwork, piping, plumbing, sewer pipe or water supply pipe, and wiring. And those cavities that are parallel to the joist are a great opportunity for insetting those mechanical systems. What we said was that when we needed to go perpendicular to those joists, well, we have the neutral axis, so we can discuss with our engineers what amount of material might be removable so that we can run some of our systems perpendicular to those parallel cavities. In addition to the sill plate or the girders on which our joists are going to sit, we also have code requirement of installing bridging. Bridging keeps the long lengths of the joist from twisting side to side. And bridging typically can be blocking. You can see it here, just a piece of board cut to the length of the cavity space, or cross bracing from another type of maybe smaller piece of lumber. Oftentimes they have now metal bridging. So I said or alluded to earlier that that joist layout will allow us now a working platform to start to build the rest of the house. And so the next step is to install the subfloor. I said in older homes might be strip planks side by side, but nowadays we do use plywood, and plywood, as they come in the 4x8 sheets, are easily attached with today's use of a power actuated hammer, much like a shotgun. The carpenter assistant puts in place a piece of plywood board. Because of the system that he's set up, 16 inches on center with the joist, he knows that as long as he puts his first plywood piece on half of the first joist, that he only has to go every 16 inches on center. He doesn't even have to watch where the joists are, because basically they're hidden under the plywood. You can't really see them. But plywood boards do come with marks every 16 inches on center, so he can just follow the mark on the plywood. Oftentimes they'll take a chalk line before they even start and place chalk lines on the board every 16 inches, one from the next, in a color that's red or whatever color he happens to have of chalk. So he has a line on the plywood that he's marked in the field that he can go by once the plywood is set snug to the plywood piece next to it. Here they're laying down the pieces of plywood to do a good job where the plywood is not going to squeak later as the subfloor. The screws are really good because, for the same reason we talked about screws and gypsum board earlier, but for the plywood they often do use a caulk, a glue caulk, to put down first on the plywood in order to secure the plywood with more than just the screws. It makes a very strong bond, and if those screws were to become loose, there might otherwise be squeaking in the floor, and the glue would help nonetheless keep the plywood in place. Here's a close-up of the power gun. We do have things that need to be left open in the floor, maybe a stairwell is going there, or pipe penetration, so it's easy to cut with a power saw. Of course, there might be instances in the flooring, because of penetrations that need to take place, that the joists are sometimes not 16 inch on center. They might be less. Generally, they're not going to be more. This is that chalk line I was talking about. This is a chalking tool. You put a color powder in there. One person stands on one end with the dumb end, as they call it, of the chalk line, and the other one's holding the chalk reel itself. And it's a snap. It's pulled taut, one guy here, one guy there, or sometimes they have a little hook. One person could do it themselves. You hold chalk taut and you snap it. Here's the guy snapping it. When it hits the plywood, it leaves a very light color line, and that's the line that carpenter with the pneumatic tool is going to shoot that plywood into the joist at that location. I talked about subfloors in older homes which were just boards. later to be covered with tile or carpet or some kind of finished floor. But that, I wanted to show you that type of subfloor as well. In many worn locations, those boards might not be good anymore. Maybe this is an area under a bathtub, might show some wear, so you'd want to replace that. You need a secure and stable subfloor on which to put your finished floor. So together with the joist, the subfloor becomes monolithic, acting as one large assembly. Oftentimes the plywood pieces might even come with tongue and groove edges. This is not plywood, but this is solid oak flooring, but they have tongue and groove. You can see the tongue and the groove, and they go snug one against the other. So in addition to the gluing and the nailing, this interlocking action helps the floor stay solid and keeps it from any movement and any possible rubbing or squeaking that would occur. There is a 1/8 inch gap that is often recommended between the pieces of plywood, and even that is kept by that tongue and groove, keeps a little distance for expansion and contraction of the wood material, the plywood material itself. If it gets wet, allows for a slight expansion because that plywood floor before the rest of the house is there, most likely be subject to moisture, rain, or other type of humid conditions. The new plywood floor now becomes a working platform. So I mentioned earlier about the moisture content of wood and the drying seasoning of that wood, accounting for the actual size of a 2x. We're going to call these pieces of 2x4 or 2x6 or 2x8, 2x10s, 2x12s, simply 2x's. We're going to call those 2x's because for our purposes they're going to already have been in place. It doesn't matter really for us whether they're 2x6s or 2x10s. So we're just going to notate them on our drawings as 2x's. And this is just to show you what happens to that wood because of the moisture content when it's green, when it's first harvested, and after it's been dried. And we want it to be dry to about 20% moisture content because at that point our building is not going to be subject to expansion or contraction of the wood material. The wood, like I said, is seasoned, and it's done in two fashions. It's seasoned either in a kiln for quick drying, or it can be air dried. Here's a picture of the air circulating around some freshly harvested wet lumber or green lumber. It's allowed to sit out of the weather in sheltered areas, but the air circulating around it is what's going to dry it out. Here's a guy taking a measure to see when the wood is ready for distribution. So here again is the real moisture content in that freshly harvested log. I said earlier that up until about 8 inches, the amount of shrinkage in the lumber is a 1/2 inch in the width and a 1/2 inch in the height. And once you get to a 2x8, it increases to 3/4 of an inch in the height. Here's the exterior wall of this house. This slide is simply saying what I had said earlier about the width of the exterior walls going from 2x4 inches to 2x6 inches to accommodate the depth of the thermal insulation that goes in those walls as required by the newest energy codes. Interior walls, however, could remain 2x4s and often do. We can still put some insulation in there if we want sound attenuation between, say, a bathroom and the dining room. We're going to talk more about that when we talk about acoustics. But here I want to show you the insulation secured between the studs. The inspector will come out before the sheetrock can go on and inspect the insulation. He's already come and inspected the installation of the 2x's as well as the foundation and the floor. And the next step after the installation of the 2x's was to put the insulation in, and that's an inspection that the building inspector will come by to do before he allows you to continue to cover up those studs and insulation. Just some more construction pictures to give you an idea of how the openings occur for windows. We also have similar openings for doors and other types of pass-throughs. You're going to notice that at those openings, the studs are doubled up to give some extra rigidity or stiffness to the wall. It also shows you here that the walls can be created on the ground and lifted into place, or they can be simply built in place. This gentleman is has built partitions on the ground. It's going to lift up into place, secure them into the sill plate. It's sometimes easier, as you can imagine, to build the partition if it's light enough still to be pushed up into place. Much easier to build them on the ground. You don't need a ladder, and the construction process can go a lot quicker. So we have the sole plate, or the sill plate, also known as a sole plate, at the floor. This is true even at the interior walls. And the same at the top plate, and in between we have the studs doubled up where there are penetrations or opening. The top plate is usually doubled as well. So here's some interior partitions. You can see the sill plate, the top plate, and the studs. Everything needs to be plumbed. They use levels and lasers to make sure the walls are plumbed. They're not always going to be 100% plumb or square to the ground or floor, and we're going to talk about that concern in another module. But the framer, in this case called a rough framer, only needs to attain a certain tolerance, not as fine as the finished carpenter that's going to come to the job later on. Older houses used to have framing 24 inches on center. So if you're working on an older home, you may wonder why the studs aren't based 16 inches on center. Well, before there was actual empirical data, there were building codes, and the building codes there did allow 24 inches on center. Depending on how much demolition you're going to do, you will probably be required nonetheless to meet now current codes, which will say 16 inches on center. Unlikely if you're doing less than 50% reconstruction that you'll have to modify everything in the house. If you're generally doing more than 50% change to the house, well then you will have to meet current code requirements. But if you're not doing that much, you will only probably need to meet the requirements of the code with the portions of the renovation that you're doing now. It's a good topic if you have a question of how much percentage of the house is being redone to discuss with the local building inspector to see what his expectation of the work is. So to the exterior studs, we are covering those and enclosing the space, making it weather tight with other types of plywood exterior sheathing, we call it, that are weather grade and prohibit the penetration of vapor or moisture or wind into the house. So there are ways to treat those pieces of plywood that are geared for exterior installation and covering them with other treatments of wrap. We call that house wrap, which are going to cover that plywood. Here's house wrap. Once applied, it covers all those joints between the plywood and any other areas where the wood exterior of the house are not continuous. So the house wrap covers that and water tightness. Over that house wrap will be installed the exterior finish material. We don't want to penetrate the house wrap with fasteners, so each of the exterior types of materials have fastening mechanisms which don't require penetrating the wrap itself. So once the house is weather tight with the exterior plywood and the house wrap and maybe some of the exterior finished material, we go back into the inside and now apply the interior insulation everywhere where there is opportunity for cold air, moisture to nonetheless come in. We also wanted to not let the conditioned air on the inside escape to the exterior. So this is a photograph, a thermal photograph of some of the hot areas, or where some of the areas of the house do leak heat, and you can see that one of those areas is the studs themselves, the 16 inches on center studs, and of course the window and door opening. So there's often not much we can do with the studs themselves because they do go from inside to outside. There's not that much we can do to prohibit the loss of temperature at that material, but there are some things that can be done, usually at a greater expense than a typical homeowner would want to do. You can see that the width of the insulation has been designed by the manufacturers to fit snugly within the cavity between studs or joists in the case of a ceiling. Also, we need the insulation at the ceiling of the top floor of the house, or in other words, the floor of the attic. Sometimes we actually do insulate the joists which form the roof themselves, those called roof joists. But it probably makes more sense to enclose the attic at the floor. We don't really care that the attic itself is going to might get cold, unless for some reason we do want to keep that attic temperate. We're going to insulate the ceiling joists of the topmost floor of our structure, right up to the tiniest enclosure. So here, even around the window, we've got foam insulation, because those areas are too small to actually get in there with other types of insulation. Here he is using a knife to stick insulation in there, but it's probably going to leave some gaps and probably not going to be as well insulated as this expanding foam would be. Safety precautions are taken. Here he's using that type of insulation which is not user or installer friendly, so he's wearing gloves and he actually has a mask on. He should maybe be using eye goggles, such as these guys are using. Okay, so here's a better picture of a guy. He's using a roll of insulation. That's pink insulation. You might know what company makes that. It's called Johns Manville. They have the Pink Panther as their logo, so their material is pink. This is called a roll of insulation. It'll beef up itself and fluff up as he unrolls it and installs it. Here is another roll. That roll is open and he's installing it. And they have little flanges that cover each stud, and you staple those little paper flanges to the studs and the insulation stays in place. These are bat insulations, and you install each one separately. And those insulation bats are stiff enough that you just stick them in the cavity and they expand enough to hold themselves up between the studs by friction. And of course too, once the gypsum board goes on, they're stuck in there and they're not going anywhere. I mentioned that at openings we do have a subframe. There's some terminology for those subframe pieces. Just suffice it to say that we just need to know we have to double things up. Even at penetrations of the roof, around skylights, the framing members are doubled up above a window and on each window side as well as doors. When we do have those openings, we call the wood frame opening the rough opening. The rough opening is slightly larger than what the finish opening is going to be once the item, whether it is a door or a window, is set in. So in this case, from the floor to the underside of the wood framing is the rough opening height, and the width from framing member to framing member is the rough opening width. And we specify that as designers so that the rough carpenter, the guy that does the initial framing of the structure, knows what his responsibility is to leave clear. The next installer, whether he's the door installer or the window installer, will have enough opening, more than actually enough opening, to stick his framework, his door frame or his window frame in. Therefore, the window or door framer, who's probably also the rough carpenter, doesn't have to struggle with getting his item into place. And we're going to talk about how you trim out the difference between the rough opening and the finish opening. There's a slight gap around that we're going to need to fill. We'll probably fill it with insulation as well as what we call shims. And those shims will refine and make sure that the door or window are perfectly square. The area above the rough opening is called the cripple, so we might have a framing member called a cripple above it to stiffen the opening. We might also have a regular 2x to fit in there. So one way or the other, the load of the house above that opening needs to be spread to the sides of the opening, and that's another reason why we have double studs at those openings. So I said what the rough opening was. I didn't quite say what the finish opening was. The finish opening is the dimension once the item is in place. So here is the frame around the door, and the finish opening is the actual inside dimension from the frame face of one side or one leg of the door frame or jamb to the opposite leg of the door frame or jamb. And that's really the opening that we're going to need for the element or the door or the window that's going to actually go into that frame. So we have the rough opening necessary for us to give to the rough carpenter, and the finish opening, so the installer for that element knows what we've allowed for the actual window or width of the door. I talked about the cripples above the door, or the likelihood of putting a header above that, which is just another 2x doubled up to run from side to side of the rough opening. So here's a header, and the rest of the distance for the height of the room is made up with cripples. More photographs of actual job conditions. You can see the double subframe, you can see a full header above obviously a window, and some of the framing elements above some future window openings. Just at this stage I'm going to mention that these are joists as well. They're roof joists, right? They're joists in the same fashion that the floor joists are. These are joists which will be the platform for the resting roof structure on top of them. I said that if the wall is, once constructed, can be light enough to actually lift in place with one or two people, then oftentimes the framer will frame it on the ground. It's a whole lot easier than getting on the ladders to do it. Or sometimes the panels are made off-site and delivered onto the job and placed either manually, or sometimes you might have a crane come and lift them in place and you simply fasten them down. Oh, here's that case. There's a crane lifting the prefabricated panel up and going to lay it in place. The installers on the job are simply going to fasten it down. Much faster because it's been pre-made, probably a little cheaper. Maybe it comes with all the electrical wiring in place as well. Depends on who your fabricator is and what he provides. Some more pictures of the job being formed out of prefabricated panels. Each panel is labeled to match to a drawing set that the manufacturer has prepared for the installer. This type of construction does not mean to say that it doesn't require the same excavation and foundation construction that we've already been talking about. Even still, once that framing is in place, we still have to do everything else to finish out the interior, including tape and spackling, flooring, and of course flooring and finish painting. I mentioned that just like our floor joists, we have roof joists. These roof joists are also referred to as rafters, and they do take the live load of precipitation, whether it's snow, whether it's freezing ice, whether it's hail, as well as the dead load of their own weight. They are acting with the downward force on them, which tends to push them out, to flatten out like pancake, so they're thrusting. This then is a very important connection to restrain the thrust that they want to exert. We slant roofs or we pitch roofs depending on what we expect the load on them might be, and we want to shed that load rather quickly. We can do structures with flat roofs, obviously, and precautions are made, but in areas of great snow we generally want to have very steeply pitched roofs. Causes the snow to run off quickly, doesn't stress the house for very long. We have penetrations in roofs as we do with floors and exterior walls. This is a penetration for an exhaust fan. Maybe they're going to have a hood over the kitchen stove, and we need to get that exhausted out through the roof. This is framing for skylights, and it has double headers above and below, and additional framing, as you can see over here. I don't think they put it in there yet, but you can see additional framing on the sides as well. We've already talked about the 2x situation. We refer to our wood framing in terms of 2x because it's most likely already in place and doesn't generally affect our work as interior designers, if we were the architect and building the structure new or the engineer, yeah, the 2x10 or 2x8 designation would be important. What we care about is not so much the individual framing members themselves, but how much is left after the framing has been installed. So are we going to end up with an 8-foot ceiling, or do we have a 10-foot ceiling? We don't really care how the structure got there itself, but if we want to say, oh, there's a piece of gypsum board and it's on the structural frame is a 2x something, and the gypsum board might be 1/2 inch gypsum board. We're here on the clear span. We can go from wall to wall, or perhaps we're going to have an intermediate beam sitting on a separate support. So in the basement we often have lolly columns which divide the space up because we don't really care about the clear span in the basement, but on the second floor maybe we have a grade room and we want to be able to have that room clear span. So we got to get a framing member, maybe it's a piece of engineered lumber, as we talked about earlier, that can span clear 25 feet or 22 feet. And that's going to be more expensive than short spans, so we're going to go with the larger, bigger money where we want to make the impact. So here's some rule of thumbs. I'm not going to hold you to any of this, but just get an idea of what the different spanning capacities of 2x's are. Where the roof rafters meet at the peak of the roof, we do need to provide not a support for the roof rafters, because really they're pushing one against the other and restraining themselves, but just a board which gives them a positive way to be attached. So they're nailed into that board, and this assembly is also made to allow air flowing from the eaves of the house down here up through the cavities between the roof rafters and out a little space just at the peak covered by a cap that allows air to circulate in those attic rafters to keep air fresh and moving. Allows the wood to be unaffected by buildup of moisture or heat. Here's that instance that I was talking about where the weight on the roof, or the roof itself, is pancake down, but the exterior walls need to restrain it. So that's a very important connection, as well as we can add these collar ties. The collar ties will tend to give stiffness to that roof as well. But that exterior wall, roof rafter connection, very important to properly detail. Another slide for more parlance or for developing our vocabulary. So once our roof rafters are in place, well, we want to secure that exterior just like we did the exterior walls with the appropriate plywood, which will be our substrate onto which our finished roof material will be applied, whether it's asphalt roof or Spanish tile, whatever it is. We want to make sure that roof is weather tight. Take a minute to look at this slide, make sure you understand the definition as we've been discussing of engineered wood. I talked about how some plywood boards come with tongue and groove attachments. They don't all do. You do pay a little extra for that. Maybe the security of that positive fastening is less important than the budgetary restraints of your owner. It's a nicety, but your project can still survive very nicely without implementing that little expensive detail. Plywood, though I said it comes in 4x8 sheets for the reason that it's easy to lift into place, and it's part of the rhythm of on-center placement of materials in construction. It does come in different widths, so here's a 1/4 inch piece. You can see the different layers on the edge of the boards. Here's a larger piece, 3/4 inch plywood. 3/4 inch is very stiff. We use that width very often for substrate for the flooring. 1/4 inch might be more appropriate to architectural millwork, maybe cabinetry and such. So once that plywood is on the roof framing, we're going to put tar paper. It's referred to as tar paper in the field. It's bituminous sheet paper. It's heavier than paper, but this is it. It's flexible, comes in rolls, and it's overlapped. And laid on the plywood gives a separation between the shingle, which is going to get wet in the weather, and the wood. We don't want the wood getting wet, because eventually the wood may start to rot. So this paper is overlapped, so water will run down it and will not get in the seam. So the next sheet will lap this, lap this, lap this, not the other way around. We don't want this to lap a sheet, and water will get under this and just get the plywood wet again. Here's what I'm talking about, right? This sheet laps this and this one laps that, so that that overlay is not a place where water will get in. If it was the reverse, water would get right in under the lapping. There are special roof nails that are appropriately designed and finished to prohibit water penetration through any nail holes as well as rusting. This type of assembling of individual pieces is called stick framing. There's a great link to a YouTube video that I put in our module that I recommend you look at, and then it's funny to follow up with the other link I have in there, which is stick framing using popsicle sticks. So I encourage you to take a look at those two links. But essentially this type of individual piece framing is called stick framing. Wood stud wall systems are economical and widely used. There are some other framing systems. You can buy modular framing systems where you pick a plan or a design and the manufacturer will adapt his system to your taste, whether it be post and beam, plank and beam, or pole construction like a barn, or other types of timber construction. These types of systems are economical and they are widely used. They provide excellent structural performance and they make use of relatively inexpensive basic materials, and they permit the application of many of your own choices for finishes and are adaptable to practically any method of on or off-site construction. So I said that rough carpenter is the guy who's got some liberty with the tolerance within which he needs to frame, as long as the walls are plumb, the structure is sound. So the wood construction that we've been talking about so far is called the rough carpentry, and the guy doing the work is the rough carpenter. He has very few tolerances within which he has to build, other than that the quality of his work needs to be within the industry standard and the reasonable expectation that it's plumb, square, and sound. These are the guys that use the bulky tools like power saws and drills and pneumatic hammers. Their work for the most part is not going to be seen. It's the stuff that's in the walls that as an observer you don't really consider very often. It's the work that's applied to their work that we see and consider as the real aesthetics. Here's some more views of the work going on, whether it's subfloor, exterior or interior walls, staircases, overhead doors, decking. These are the guys that do the hard labor and often under inhospitable weather conditions. Installers who come after the gypsum board is on and things start to become the visible elements of the house are done by finish or trim carpenters, such as the base molding, cornice molding, chair molding, cabinetry, staircases, stair railings. Those elements that we're going to see, that we see and think of as the aesthetic end product of our idea, are the finish and trim carpenters. These are some samples of finished work. I said base molding, fireplace surrounds, cabinetry, paneling, staircases, etc. They work within very small tolerances, and we'll talk about that during another module. I started the module by saying that during the 19th century, with industrialization and the prominence of the mass production of building materials, there was a style of building that was favored. It was called balloon framing. So harvesting of lumber no longer came from your own property. You no longer had to trim and dress your own material and create your own wood joinery. But as I hinted at before, this balloon framing had an inherent issue which wasn't immediately obvious at the time of its popularity. The solution to the problem of balloon framing came through a method of trial and error, ultimately given the name of Western platform framing. And Western platform framing accounts for roughly 80% of the framing done in the United States, primarily because it's the main framing used for homes, and homes are the most popular type of building structure in the United States. Balloon framing was introduced in Chicago in the 1820s and got their name because in comparison to the former type of timber house construction, it looked much more light, like it was going to float away. In balloon framing, the exterior walls ran continuously from the first floor all the way up and through to the roof structure itself. Hopefully you can see from these few slides that the outside stud walls ran from the first floor all the way continuously up to the underside of the roof. What was being created essentially were side-by-side chimney stacks like you would have in a fireplace. The cavity between each stud was acting like a chimney flue. See in this detail that the floor joists were fastened to the inside face of the exterior wall. The cavity between exterior studs was continuous from first floor to underside of roof. What would happen was that in the case of a fire or smoke event on the first floor, such as in the kitchen, would quickly be transmitted up through the cavity to the second floor, engulf the second floor, and continue up the exterior wall to the roof and engulf the roof. So they had created side-by-side chimney stacks, as I said, and the fire spread rapidly, and this was the inherent design flaw of balloon framing. So someone came along and said, we need to interrupt that chimney and keep the fire and smoke from bellowing up and destroying the rest of the house. Of course, wood is combustible, so we're not going to be able to entirely prevent fires, but we can slow the progress of the fire down. So what was invented was the platform framing, where the floors were framed through the exterior walls, and actually the floor joists would sit on those exterior walls. So now we had, at each floor level, an interruption of that cavity and a slowing down of the spread of the smoke and the flame to the floors above. That's the platform framing, creating a platform for each floor that's sitting on top of the exterior walls. So knowing now, as I've said, you can look at these photographs and now understand why that was, from the start, was going to be problematic and ultimately devastating to the houses and their occupants. There's some photographs of exactly the catastrophic implication of balloon framing. Now, we don't do balloon framing anymore for these obvious reasons, but that's not to say you might not do a house renovation somewhere or a house adaptation, or adaptively reuse a house, or do a historic preservation where you might find this complication. So we are at a point now where we can recognize the shortcomings of this type of construction and say to our owner, this is a problem, needs to be rectified, there's no sense in going forward until we settle this issue, which is actually an imminent danger to the occupant or owner of that house. Here's an illustration of that chimney effect, just like we have in our own fireplaces nowadays. It was with this type of construction in the backdrop that the Great Chicago Fire of 1871 was catastrophic to the city of Chicago. There was no controlling the spread of the flames, particularly because the houses were so close together, they just jumped from one to the next. And the balloon framing certainly did not help the situation. When the builders realized the shortcomings of this type of construction, the municipalities began to adopt building codes. And building codes did, and still do, become reevaluated and updated when a new hazard presents itself. And these advanced techniques were developed not just in Chicago, but throughout the country. The term platform framing comes from the fact that the platforms of each level interrupt that exterior wall and become a fire barrier to the spread of the fire and smoke. So fire and smoke could temporarily be contained to a small area during which rescue operations or fire damage control operations could take place more speedily. A new element of construction also took place in combination with this platform idea of stopping smoke and flame spread. It was the introduction of blocking, intermittent blocking in the walls at places that would slow down the spread of the smoke and the fire, and that were actually independent of the structure itself. So it's just a simple introduction of some blocking, of some wood stud material in the cavities of the walls would slow down access to areas by smoke and flames. So we have here in the walls, whether an interior wall or exterior wall, the introduction of blocking. There are instances of blocking referred to as fire stops. The term blocking also refers to introduction of materials in the wall at areas which need to be firmly secured to allow positive attachment of items such as cabinetry, fire extinguishers, handrails, as well as for securing wiring, air conditioning ducts, plumbing such as hot water, cold water, drainage lines, sewer lines, things that we need to know are not going to be pulled off the wall when weight is added to the cabinets. Someone's depending on that handicap bar at the toilet side to pull on. Also to secure the work of other tradesmen. We don't want a loose water pipe dangling in the cavity between studs. We want it secured so that when the owner turns on the water, that pipe is not going to vibrate and cause a sound throughout the whole house. Some more examples of blocking. Here's some blocking was put in place for the handrail to attach securely to. Here's some blocking in the wall anticipating the location of maybe some cabinetry there. The blocking is large. The blocking is usually large, maybe larger than what we need, but we want to make sure that wherever we put a hole through our cabinet, that if we don't catch a wood stud, at least we're going to catch a piece of the blocking and have a secure attachment. As interior designers, we say blocking as required. We don't tell the contractor where the blocking goes. It's his responsibility to understand that certain things that are going to be installed need blocking. We don't tell him where to put it, we only say blocking as required. It's his job as the builder to understand the needs of the other trades with regards to securing a shower head or a faucet, as well as to understand that the cabinets, vanities and things like that ultimately need blocking behind them. So we say blocking as required. We don't specify the size of the blocking or per se where the blocking is to go. In this slide you can see some intermediate blocking for maybe stiffness of the wall or fire stopping purposes here. He's taking a piece of plywood, large piece of plywood, more than probably what is needed for a pedestal sink installation. So he gives himself a good width of space, make sure that wherever the pedestal sink or the vanity is going to be attached, there's something there. A list of some of the places where we would need some blocking is shown in this slide. In wrapping up, I just want to go over the sequence of building a stud wall. As we said, we have a 2x joist with the subfloor, probably a piece of plywood, designated as layers of plywood by those straight lines. At the floor level and directly above it, the joist for the floor above or the ceiling above, which is forming perhaps the floor of the floor above. Not always directly above it, but we're going to use that for simplicity's sake. That red line is simply to show that they're on center, this joist with that joist. The next step is the introduction of a plate, a sole or sill plate at the floor where the partition is going to go, and directly above that, the attachment of the top plate to the joist above. If there's no joist there, then it simply gets attached to the plywood of the floor up above. And the introduction then of a 2x4, or in the case of an outside wall, a 2x6 stud. The stud's every 16 inches on center, so that's a pattern that we know established when we talk about on center. It could be 25 inches on center, it could be, but it's not. For stud construction, it used to be 24 inches on center, but now it's 16 inches on center. So we have now the structural elements of our partition. We now introduce to the face of those studs and plates our piece of gypsum wallboard, GWB. Depending on what our intended use of the wall is, it might be 1/2 inch, it might be 3/4, might be 5/8. In this case, showing a 5/8 inch element at the wall, and then to the underside of the floor joist, we are attaching the ceiling gypsum wallboard as well. So we have very roughly the beginnings of an actual detail. When I talk more about the drawings that are going to be due, and I talk about details, right now we're not a finished detail, right? We're only at a composite. Right now we're only developing a diagram of a detail. So we have some of the elements, we don't have all of the elements of our assembly. So we have a floor situation beginning to be developed, a cut line because our wall is not here, we don't have enough height here to show a continuous wall, the other cut line, and then the ceiling condition in our space. To that gypsum that we've just seen, we now introduce a floor base on both sides. In this case it's a wood base, and we are introducing how the wall ceiling condition is going to be. In this side of the wall we have simple tape and spackle corner, nothing elegant, maybe it's just a closet in that side. On this side, however, maybe it's the dining room, so we want to have a piece of crown molding that we want to introduce to make that wall to ceiling connection. So here we do have a finished assembly. This is now a detail. In fact, this is two details. It says detail, it says detail. Sometimes you're going to see in my PowerPoints that it says diagram. Diagrams are not details. Diagrams are only small beginning of the development of a detail. But a detail is a composite assembly of everything that's going to go in to that particular area or that particular assembly. It's finished, that's it. It's no more to be added to. So here we have finished detail at the base of a gypsum wall partition, and here we have a detail at the top of a finished partition meeting the ceiling. In this case it's tape and spackle, and this side it's crown molding. This represents two details. There's a cut line, it's not continuous as one detail. It shows that that wall lines up, the top of that wall and the bottom of that wall line up. And so together we have two details. We have a requirement of two details. So the requirement for the number of your details could be satisfied to begin with by these two. So two details, complete composition of an assembly. So to reiterate, this is a horizontal vertical. This is a this is two vertical details through a gypsum wall wood partition. These are what you need to draw for the drawing assignments that are due every 5 weeks. This one is done on grid paper. You can use grid paper too. It will help you to make a straight line, and you can draw at scale if you buy paper where one square equals 1/4 inch. I want you to notice we draw actual sizes. So in this case, if 1 square equals 1/4 inch, a 5/8 inch piece of gypsum wallboard. So on this grid paper, the student has shown 5/8 inch gypsum wallboard as a little more than 1/4 inch, where they have assigned 1/4 has shown 5/8 inch gypsum wallboard a little larger than 1 square, where they have said that 1 square is equal to 1/2 inch. So 5/8, a little bigger than 1 square, which they designated as equal to 1/2 inch, and a 2x4 sill plate is actually 1.5 inches by 3.5 inches. They've shown the 1.5 inches as being 3 squares, each square equal to 1/2 inch, so 3 would be 1/2 inch by 7 would be 3.5 inches, right? We have so here we have 2 squares an inch, 2 squares another inch, 2 squares another inch, that's 3, and another square, that's 3.5 inches, and for the width we have 3 squares, each representing 1/2 inch, so that's 1.5 inches. We have 1.5 inches by 3.5 inches. grid sheet where 1/4 on a grid sheet where there are 4 squares to an inch. There will be enough details that you can copy right from the PowerPoints before the end of our 5th class, so you don't have to invent details, you don't have to look further than the PowerPoints, which we've just now started to be introduced to so you don't have to look further than these details that we've just now started to become introduced to so you need not look any further than this PowerPoint and the ones in the next few weeks for details to be drawn for your homework or drawing assignment. What you need will be sufficiently supplied in the PowerPoints between now and the 5th week and then going forward. So you'll have enough details to satisfy the drawing submission assignment. Here we have 2 more details. This is a horizontal section through a partition at a corner. We have a typical wall, horizontal detail. You can see the gypsum board on each side, 5/8 inch, a little bigger than a one grid square, and a 2x4. We make a note, 16 inches on center to the next 2x4, and we can see here a joint where 2 boards come together, finished with a tape and spackle. We do like to alternate our joints from stud to stud, so we don't have a weak point of this joinery with a weak point on this joinery, because sound will travel through those joints if they were to line up. So we like to alternate our joints on a stud. Don't have them line up from side to side of that stud. And then we have a corner condition. We have a 2x4. We have another piece of 2x4 to help us form the corner. We have a corner bead on the outside edge that gets spackled so that it's a strong corner. And we have inside corner simply taped and spackled. So actually, this is the same wall. It's centered. The red line indicates that it's centered on each other, this detail with that detail. But because of the cut line, we actually have 2 different details. So here's 2 more details that you could actually use for your first drawing submission. Another 2 details, this time of plaster on wood frame partition. So 2 vertical wall details. These walls, instead of gypsum wallboard, show plaster construction. We have the same 2x joist supporting a plywood floor. We have above and the floor above another 2x joist supporting the floor above with the top plate and the bottom plate and the stud running every 16 inches on center. Doesn't look like much because we're really just looking at the face of the stud, right? We're not able to mark it with the X as we did where it's at a cut point. It's just the surface, so it's just 4 edges that we're seeing, empty in the center, but we call it 2x4 stud, 16 inches on center. I like to say beyond, because at that point where we're cutting through the wall, that stud may not be right at the surface. That stud may not be right at the surface where we cut. It may be a few inches or more back. So I like to say 16 inches center, 16 inch on center beyond. But attached to that stud, we have our galvanized metal lath screwed to the stud. Then we have our 3 layers of plaster. We have this 3/8 inch scratch coat, which is going to penetrate through there, make a key, and hold the rest of the plaster on. The next coat being a 1/2 inch brown coat that gives the massing to the plaster wall, and then an 1/8 of an inch finish coat. So on top of that stud, then we're going to cover the grounds with at the base a piece of wood base with a nice little profile. And at the top, this ground is going to be covered by a crown molding on each side. So we have a vertical section of a plastered wall. At the floor and at the ceiling, we have 2 details for your understanding and use. Thank you.